Oh, I think we just rewrote this term in the different terms. So this control function is like useful. Okay. So it says apparently things can get tricky. So we're gonna write an implementation of bracket using this thing. Monad base control. LM. MB. So this bracket function, if it's not something you've seen before, it basically handles like automatic release of like resources. So if you want to like open a file and do something to it, but you know you broke your code or something and you need it to close, or you know your I don't know your network dropped or something, it would automatically like close the handles for you. So it's a pretty useful function. So apparently this is incorrect. I think it should be control run bracket run acquire run. Why is that in parentheses? There might be a reason for that. I don't actually know. Okay, and then oh, so I think we just get rid of this X. We just write control here. We need bracket. Control exception, or I don't know where the right where's the right one I'm supposed to grab. Probably just here. But this isn't generic. It's this one. Control exception lifted. Control exception lifted 11. This just works? Says I'm supposed to get a compiler error. I'm supposed to get an error. And I'm clearly not getting an error. We're getting redundant do, right? That's obvious. So I guess let's try this. Oh, whoops. Just to make sure I'm not missing something. Like a type. I just want to make sure nothing is wrong. Yeah, see, this is basically what I was expecting there to be some other issue. I thought I included lifted base. Whoops. So vim package. Oh, I don't have that. Okay. Lifted base. Yeah. All right, now let's try. Is there I should expect? Could it match R? Well, this is different. Equation for bracket. Oh, maybe I'm missing a um whoops. An argument. Release. Require release use. MR. R to MB. Yeah, I'm missing. Okay, it's there now. Maybe I can't use control? Okay. Try do is lift base with this whole thing, then restore. Let's see if these. Can't imagine that this actually matters, but in the book they have parentheses here. The only thing I'm thinking is maybe I'm using the wrong. Yeah, no, I think maybe this is the wrong bracket function. So, but I don't know that for sure. Let's use this one. Control exception base, maybe. Control. And then see what that does. Hmm. I want the generic version of this function, basically. I want M. This one. I tried that. Did I like write this function at one point? Code doesn't work. Unless I have it here somewhere. Control. Exception. Although maybe this is, so what I should do is go look at the source of this one. Because maybe this is just the correct bracket function. Where does this bracket come from? That's probably the one I want. E. Yep. Control exception. So that should be the control function that we take. And then let's see if we can remove these. Sorry, I'm sort of trying to figure out how this code works. And we got restore M problem. Would it match arrow R with IO? Well, it's sort of the same. Okay, let's see. I mean, it did say it's gonna error, but you know, I figured it was gonna be a better error, or like it's different than the one in the book. That's kind of that's all it is. So let's see if writing this other version fixes that. So lift base with run bracket. And then this is run restore MR. I think that's why those parentheses were there, is because they're just going to add them again. So restore MR use. Okay, so that fixes the error. To be fair, I didn't get the same error, so it was kind of hard to fully understand what was going on there. I should also, whoops, I should remove lifted base because I don't actually need that. The reason I said oh is because I shouldn't have closed this, and I did because I'm a doofus. Anyway, all right, so apparently this doesn't work. So it says, even though this implementation type checks it's wrong, there are 3 moments where some transformer state might be modified, corresponding to the 3 functions. The resulted bracket returns the value from the use branch. So it's supposed to return the value here. This means that the effects that may have happened during acquisition and release are completely ignored. Apparently there's a talk by Michael Snyman? Is it Michael? Pretty sure it's Michael. Yeah, sorry. I know his last name. That basically showcases this error. So if we use this bracket function, we can write the following code apparently. Foo state t list string IO unit foo bracket prime modify. What's modify? I have no idea what modify is. It's probably something to do with state, I presume. Well. R3, R2, acquire, release, use. And then okay, we wrote foo in here. Uh, so control monad trans state. And then what is modify? Expected type unit 2 with actual type. Is this part of state? Where does this come from? Modify. Okay, so modify just modifies the state. So just takes this function and gives me a state t. So I guess it just needs to be like so. Okay. Nope, 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 nope. Comma F. Main. Alright, and then here we're gonna try and use this thing, and I presume that it's going to print out of order. Res exec state t foo dlist print res. We need import control monad trans state. We really only need exec state t. Just take anything we need, and then we can format this right quick, and then okay, control Z, stack, run. And then in theory we should get those in the wrong order. Oh well, that's interesting. Okay, so it says most people would expect that after the entire acquisition release cycle, the value of the result should be 1, 2, 3. Instead, you get 2 printed to the screen. Well, we get 1, 2, but okay. I imagine that this is something that just has changed in like newer versions of Haskell or something. My recommendation is to keep unlifting to stateless transformers or use a package targeted to a specific kind of function, such as exceptions or unlift IO. How do I fix it? I mean, so what's the correct implementation? It's got to be the one in here, I guess. Let's go look at that. Bracket, and it's going to be in this one. All right, so we need run in IO, which we were using, I believe. And we have bracket, we have this thing. Okay, so let's see if that fixes it. So We'll change this to control. This will be a redundant do, and we don't need that anymore. Then we need to deal with this run and IO stuff. Oh. This is the same thing. Yeah? Run. R to run restore M after. This is the same implementation. This doesn't work. What it just said. I don't understand. I don't understand. So what's, if this isn't correct, what's the right answer? It just says keep unlifting to stateless stateless transformers. Okay, I think they're just trying to warn you that this doesn't work quite right. I think that's all they're trying to do. That's fine. Okay. More on manipulating stacks. So that's section 12.4. So we'll start here. What's going on? Thank you. Okay. So the monad trans type class allows us to lift an operation from a monad M into a larger monad TM. However, lift is restricted to adding layers on top of the existing ones. But what if the layer we want to add has to be not at the top, but at the bottom of the stack or an intermediate position? The mmorph package provides a set of operations to handle those cases. Excuse me. There's one easy case. If there is no layer at all, that is, the computation is pure, we can create that single layer using return that has a type A to MA. It is interesting to create a version of return that converts from the identity monad into any other monad for reasons we will see below. All right. So I probably already have identity. Why did you do that? What is happening? You might already have identity defined, but we can deal with that here in a second. Oh, and we have a new type. I want to write why is this? What is this going on about? Okay. Now let us consider the converse situation to the one at the beginning. Remember that reader, state, and so on are really synonyms for transformers applied to the identity monad. The monadic computations you want to compose are as follows. Or I don't understand what it's trying to point out here. The intuition here is that we need to apply generalize to swap the first monadic computations you want to compose are as follows. Hang on. Confused at what it's trying to explain to me, which is a very common occurrence. String int. So keep in mind that this is really reader t string identity. Okay. So we need to apply generalize to swap the first identity for maybe. But we need to do so under the common reader t prefix. Reader t, okay. Such an operation is called hoist in the mmorph package. Okay, so let's look at hoist. We're done with this, I think. Oops. Hoist. Not from streaming, from mmorph. All right, so for all a m to n tmb tnb. Interesting. Okay. This type looks a bit more complicated than usual. Reading it will show you that it encodes the same idea. You give as an argument a function that converts monadic computations from m to n, and hoist takes care of applying it within the given scope of the transformer t. One possible argument is generalize. Okay, so let's do the following. So where is this? Control monad morph. Do I have generalize? I do. So I can do type hoist generalize. Oh, right. So hang on. Really? Where is it? I always forget where it is. Functor identity. Data functor and then this needs to be identity. Okay. And then reload, import this, and there we go. All right, so if we hoist this, we're basically taking an identity, like a reader T identity into a new reader T. How do we do with the int? That's the part I don't see. Okay. Oh, right. I need to get a value out of it. So can I do this? Probably not. Right, and then the type of G2 is this. So basically what I'm doing here is saying, if I hoist this and pull out this integer, I can take G2, feed it the integer, and then get back this hoisted. Hey, what's going on? Not sure what that's supposed to say. But what's going on, Uni? I'm not sure exactly how to pronounce that, so I'm gonna go with Uni. Okay. So we got this hoist thing. The combination of hoist and lift becomes useful once you start working with stacks of 3 or more layers. Although humongous monad stacks are usually a code smell. Imagine you need to compose computations to these types. Okay, so we're gonna do some more here. So G3. Oh, we can do H1. I'll just use the same types they have. State T, counter, maybe int. I don't know that counter is a thing, so we may just have to pick something else. State T, counter, reader, T, config, maybe. Cool. Alright, so let's just put some stuff here. String, string, string. I don't know. Int. Okay, so this is something like bar do hoist generalize G1 G2x hoist to. Okay, and then that type checks. So we can actually check the type of bar now, but it should be this, if I recall correctly. And that should all type check. Okay. So now we're going to write as okay. Let's do some commenting here for later. So hoist is for all AMA NA. That's right, it doesn't need monad n. TMB TNB. So something like this. So here so specialize hoist state t string wait, why? T this is clearly supposed to be a B, right? It's gotta be a B, I think. So what we need is a function that takes M, which is a maybe, and gets us this. So I guess that's our lift function. We should be able to write as this hoist lift h1. Whoops, what did I just do? It's not what I meant to do, but okay. Meant to do that. But maybe we're not done yet. So this is like this. Yeah, okay. I'm stupid. Sorry. I should have just looked at my jobs. Okay. So this is not where we want to end up. Right? We're close, but we want to end up at bool. That's the idea. We're trying to end at h2. We're basically converting h1 to h2. Okay, so we have this squash function. How does that help us? I don't see how this helps us yet, but um, it essentially resembles join, which we've used before. That's it. There's not even the right type. Okay, I think that this is supposed to be bool. That way these outer ones match, and you're basically just modifying this maybe. So I think that's probably what it was supposed to be. But there was an int here and an int here, which I don't think makes any sense. If you're trying to turn this into this, you can't do it with int bool. It has to be either bool bool or int int. Like, it doesn't matter which one, it would work with both, but that's the idea. Okay, anyway, so it says do it says having this squash thing actually has deep significance. It means that transformers supporting squash are monads over monads. Interesting. That's pretty wild. Monads over monads. Monadception. I guess this is the second layer of monadception because we're already doing, transformers, which are stacks. Is that monadception? I don't know. My girlfriend just walked by and said Transformers, the show. That should have been the title for this book. Transformers, Monads in Disguise. You heard it first. Okay. The next section is called Monad. Oh, so yeah. Apparently, the existence I'm not gonna write that here. It's too deep. Okay. Not every implementation of lift that has the right type is fine to use within monad stacks. It needs to respect the monadic structure. In particular, we should ensure that binds and returns are respected. Okay, so as an example, so what is it? Not every lift fine to use. It must obey the rules. So these are essentially the rules. Lift dot return is return. lift dot f g equals lift f what's run? Oh, sorry. Doing the wrong thing. I'm reading ahead. Okay. So it needs to obey these. So it says hoist f is only a monad morphism when f is well. So essentially these are okay, must obey the monad morphism laws. Monad unlift IO at run function similar law must obey the above law. And there's another point here that must obey the above law and an additional law with run in IO, run lift IO, run M, M. Oh, and this should be here. Okay, so apparently this unlift IO business has more laws that it needs to follow. But basically this thing here states that if we just unlift the computation and lift it again, things are kept unchanged. But on non-stateless monads, with run IO would need to save the state. That's a weird way to say it. Non-stateless. Just say, we could say state full. We would need to save the states, and any further modification done by M would be lost. In this part of the book, we've considered the issue of combining operations from different monads into a single computation. The task is far from trivial. Monad transformers require some advanced programming patterns. Unexpectedly, the issue of combining custom monads is easier to resolve than combining the usual state, reader, maybe, and friends. Okay, interesting. What's up, viewers? If you've never seen us before, I just noticed the number popped up kind of high. If you've never seen this before, basically what I'm doing is I'm reading this book, Book of Monads. I'm now on chapter 13, and chapter 13 is all about defining custom monads. So in the last chapter, we learned about sort of like how to lift and unlift and add layers and these sorts of things to monad stacks. It's pretty crazy stuff. That's not what I wanted to do. Okay. We only have a few more chapters of this book left. So we're getting towards the end. It's literally in its home. Okay. 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 GitHub, com, Berrymoo, book. What's up, Warren? Do. Okay. Create. I know this isn't like the most beautiful thing, but I don't really care. Git checkout master, git pull, git branch d tutorial. Stack new chapter 13. Nope. Thank you for aborting. It's sick. Ugh. Ew. Don't get me sick, Oren. Luckily, the internet doesn't work that way. Could you imagine? My goodness. I'm sorry you're sick, though. That's no fun. Eek. Yeah, that's an issue. It takes a long time for them to get their immune systems figured out, so that's unfortunate. Sorry to hear that. Did you like just start it, or are you on the tail end? Oops. Do. That's good. So at least it's going away slowly, but I know that doesn't. Not very helpful right now. Okay. So what do I want over here? Okay. So we got GHCID over here, and we got our editor over here. We don't always need GHCID, but sometimes it's nice to see the full output. We don't see the full output in Vim, so not particularly easy. Grim, RW Grim, thank you so much for the follow. I really appreciate that. That puts us at 161, I believe, which is pretty awesome. Are you a Haskell person or just generally interested in programming? I would be interested. Stopped reading in chapter 11. Need to catch up. Oh, programming streamer. Awesome. That's awesome. What do you stream typically? What's this little battery? What does turbo mean? I don't even know what that means. Which turbo? What is that? I don't even know what that is. But okay. Neat. I've used Pigeon a little bit. I tried to use it for as a replacement for like Skype for Business. It didn't quite work exactly. Ah, I got it. Yeah, there's just like a little battery next to your name, and I've never seen it before. But Pigeon looks pretty cool. Yeah, it's just the video. Actually, the voice was working okay. I just couldn't get like video working for whatever reason. It, it is what it is. I mean, we shouldn't be using Skype for Business at work, so hopefully that will go away eventually. Although now I guess I'm using Microsoft Teams, which I'm not sure is any better. Well, they basically Microsoft already said that they weren't going to support Linux, so you kind of are just on your own. Hmm. Oh well, is it? I thought they decided they weren't going to do that. Maybe I misunderstood. Uh, huh. Yeah, maybe I misunderstood that. Out of curiosity, did you find me through the awesome list? I was just curious because you're another streamer, or you just randomly saw me. We wanted to know if that was actually working. I submitted a PR yesterday. What's up, programming guy? Nice, cool. Well, I'm glad you found us. That worked then. So there was someone Tenchi who found that. I hadn't seen the list before, and he suggests. Well, I think it's a he. To be fair, assuming gender in 2019, um he they suggested that it's an awesome list for developers, streamers. Here, I can find it. I submitted a PR there yesterday, so um, oops, I didn't want to click mine. Here you go. Oop, oop. Go. Oh yeah, yeah. Go ahead. You can post the link, Grim. I would like to know about it if it exists. Um, I was using the some snap. Sorry, I'm just quickly looking through this. Actually, I might save it for later, so I don't have to look at this second. Oh, nice. Yeah, so the I don't remember what client I'm using. It's some Snap on Ubuntu. Uh, but it seems to work right now. It does video, it does all the things it needs to do. But I need to spend more time looking through this because there's like a million of like a million streamers, and I don't know which ones are like actually active or not. And also I would like to find more streamers to watch. Just like I don't really want to watch um it, I'm opinionated and I don't want to watch what I don't want to watch. That's what it is. So, but it would be nice to spend some more time with that list. Okay. Yeah, the other one as well. Programmingstreams.net. Yeah. Belly.io. Yeah, I mean, any list would be great to be added to. Oh wow, that's really cool. Here, I've never seen this before. But it shows people streaming right now. I assume this means. Oh no, I was assuming this meant YouTube or something, but that's cool. Advent of code, fun, neat. I've not seen this before, but yeah, I wouldn't. I mean, anything I can be added to. I'm gonna save this up here as well because I'd like to look at it later. Um, cool. Okay, I will save that. Yeah, for sure. I'm not surprised that there's so many advent of code folks. What's up, Bloomy? How's it going? Thought you said you weren't going to stay up late. Happy to see you. Hmm. All right, I should probably start actually writing code again. So this chapter is all about defining custom monads. So I think we're going to begin with a tic-tac-toe board, essentially. Um, you Okay, so it says a computation in the tic-tac-toe monad describes the actions that a player takes in a particular run of the game. Since the gameplay has this inherently sequential nature, we only decide what to do next after each move of our opponent. The concept of a monad fits very well into that idea. However, having a bind and return is not enough to describe a game of tic-tac-toe. We need additional functionality in order to query the state of the board, like whether each position is already taken and by whom, indicate what we want to claim, that we want to claim an empty position, and know whether we have already won or lost. Okay. We refer to the functionality that a particular monad provides as the primitive operations of the monad. We sometimes drop primitive and just speak of the operations of the monad. For example, get, put, and modify are the operations of the state monad, and M0 and M plus are the operations of maybe and list. By putting together chains of primitive operations, we can describe an entire computation. Okay, wonderful. Complete the definition of the position data type. The value of this type represents a position in the 3x3 board to play tic-tac-toe. Got it. Oh, won't stay long? Yeah, I mean, I don't blame you. All you folks overseas, pretty tough. Pretty tough. Okay, so we're gonna have data, position. All right, so if we want to recommend, um, yeah, except this doesn't quite work, because it's we need it to be constrained. So let's constrain it. Ow. So let's call this board position. Right, because it can't just be any row. It can only be either the bottom, middle, or top row. And the bottom, well, that's really the left, right. You know what I mean? Let's just use bottom, middle, top. I don't really like these names though already. 0 viewers. Is it broken? Or is everybody left? Sad. There's too many good streamers. Everybody left. I guess I don't blame you. I'm boring. I don't think I'm. Yeah. Um. Something like this. Just as an example, I guess. Okay. It says, you might be convinced that we can define a monad for playing tic-tac-toe. The natural question then is whether we should define one. What do we gain by modeling our problem with a monadic computation instead of hacking our way directly to the solution? There are reasons for doing so that come from two areas: domain-driven design and domain-specific language. Domain-driven design provides a philosophy and framework for how to design software, where DSLs are a way to turn those ideas into runnable code. Da 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 da. Oh my lord. So this is sort of just an aside on domain-driven design and domain-specific language, but there's like a lot here. I mean, a lot of text. So it says, think of a domain in which you want to model a behavior or process. Think about all the parts you would need to implement a custom monad for. The primitive operation. Yeah, okay. So I'm gonna skip that exercise because it's, again, a lot of work. I vaguely remember doing this in thinking with types, but I don't remember exactly how we did it. I mean, we're basically modeling this as a matrix. But I thought there was some sort of isomorphic way to do it that was maybe more interesting. Anyway. It says describing behaviors and processes within a DSL. So apparently we've picked that we're gonna make a DSL. So we'll go from there. So you. Okay, so it says, so we're gonna embed. I don't know what we're doing, but apparently we're gonna use final style, which is good because I'd like to learn how final style works. Just assume that this thing is broken. It says the main driving force behind final style is Oleg Kiselyov. I have no idea if I'm pronouncing that. It's very similar to the MTL style of monad transformers. Apparently we'll see more of the final styles coming up. It's easy to combine operations from different monads into a single computation. Okay, anyway, so We're going to take a board position. I think usually X goes first. I don't really know what we need to derive yet. I feel like there's a way to do this that is not this. Let me look real quick. Because if I remember correctly, there's like a really interesting way to encode a tic-tac-toe board. But it could be hard to find. Is there an index in here? I hope so. There's no index. Give me a second. I'm pretty sure it was in the cardinality channel. Oh yeah, here we go. What's an A? All right, so we're gonna try and use this implementation. What does A mean? Tic-tac-toe A. Oh, A is probably this, like a player. All right, let's use this instead. So we're gonna have 3. Oh yeah, it looked like everybody sort of disconnected. I don't know. My internet seems fine. Awesome. Developer. This one. And then another one that was, yeah, that's fair. The other one was Belly.io and Belly.io, which I've never heard of these, but I did go to them. Programming, make sure it's right. Streams.net. So those two were also available. I had not seen these, so it's nice that that person told us about them. All right, so 1, 2, 3. So let's put some, so bottom. Yeah, we'll go from the bottom left corner, I guess. So bottom, middle, top, left, middle, right, something like that. These are going to be 3. So that's the board position. But what's info mean? So what I want to do is get rid of this. And we're going to change this a little bit. So we're going to take 2 3s and create a M maybe player. I don't know what take means here yet. And I need to see what a result is as well. So the cool thing about this is that if you do it this way, you can write like an empty board. Give me 1 second, I'll explain. I'll just write the empty board. So there was an interesting thing from this book, by the way, which we actually did on stream as well. You can get the videos on YouTube if you want. Thinking with types about cardinality and how you can model tic-tac-toe board slightly different way and write slightly more interesting code because of it. All right, so result already taken by player next turn game ended winner. So we're gonna have to probably do some modification to the code, but you know, you can have like an empty board, which is like tic-tac-toe what's this M? I guess it doesn't matter. I don't know what this M is yet. This is probably this final style. I don't know what this is yet. So hang on, bear with me. We'll keep going. Okay, so it says a computation that uses these primitive operations receives a polymorphic type that reflects this fact as a tic-tac-toe constraint. Okay, so here, now I think I understand now. So like an empty board is like monad M tic-tac-toe M 3 3 and then sort of the interesting thing here is that it doesn't matter what you're given, so you can basically write const nothing, I think. Yeah, right. So by modeling it this way, you can basically like ignore these because you're dealing with an empty board. So it doesn't matter, like if you want to create an empty board, it doesn't matter what's given here. So you can just say like, ignore these. That's what this const.const does. And then what we need is some monad of a maybe player. So we'll say maybe player is nothing. We'll return it because we've given the monad constraint, so we can make this no matter what. And then we just throw away the first two arguments. So that's what const does. So you could write this in two ways. You could write, you know, something like this if you wanted to. Doesn't really matter how you write it. I usually like to push my dollar signs as far right as possible. But this comes to you because of the way you model your board. Our tic-tac-toe board is like a 3-3, 3-2-3-2 something. So that's kind of interesting. All right, so that's kind of the idea. And then I think we're gonna write another. Okay, so we can write like this function as well. So take if not taken. One thing I'm a little confused about is how this and, well, just, yeah, this tic-tac-toe thing is going to result in saving the current state. Like, how do I know? Oh, thank you. Yeah, I have to rewrite this a little bit. So somehow we need to save the state of the board as like a series of 3 threes or something. I'm not even sure how this is going to be done, but hopefully it will become clear at some point. Anyway. So apparently we can say so row all do Can we start hiding stuff from Prelude? Import. Can you write? Hiding take? Is that a thing you can do? In roll call. All right, so right now we're modeling primitive operations. So, and then I guess we're gonna build up primitive operations. By the way, this wasn't in the book. I was just trying to show the point of why you try to model the tic-tac-toe board like this instead of as, like all the positions on the board, or something like where it, like the rows and the columns. It's the same thing as this. So anyway, the cool thing is that this more or less is exactly the same as what's in the book. The only thing that changes is that this is a P in all 3 of these cases, and this is a position. Those are the only 2 things that change. So that's kind of neat that it just sort of works, which is not really that surprising. Okay, anyway. Why does this need to be a maybe? Why do we need a maybe result? I'm not entirely sure why we need a maybe result. There's probably a reason for it, which we'll encounter later. Maybe we don't even need it and we can remove it later. But anyway. Okay, so now we need to make tic-tac-toe the monad, I guess. Wait, what? Oh, I see. Okay, so it's pointing out that we could just write tic-tac-toe M here if tic-tac-toe M made sure that M was a monad. Otherwise, we need to write this every time. So if we wanted to remove this from both of these primitive functions, we could just stick it here as a constraint to the tic-tac-toe class, type class, excuse me. I was confused at what it was trying to show me. Okay, so the final ingredient is how to interpret a final style monad as an instance of the corresponding type class or trait. Since we have more than one instance for a single type class or trait, naturally retain the ability to have multiple interpretations of the same syntax. Okay. So here's where this is going to get complicated, because we'll have to basically deal with this. So we're talking about a type board, which is a map of position and player, which is a problem, right? So the problem is that a position is really this. Right? And you can't store this in a map. So, I suppose we can just go back to the other case. So I think what we need to do is just not do this, or do the following. I suppose we can do the following. So let's do, because there's really no way to deal with this, we'll just convert. We can say we'll just write a function 3 to 3 to position or something, which is really going to be super easy. I want to put this, oops. So a row is a 3, column is a 3, and you can write the function to position, which is going to be 3 to 3 to position. Right, so if we have 3 and 3, we'll just stick them in this data type so that we can actually store the board state. Otherwise, we're not going to be able to store the board state. That's kind of what I thought. So there's like, I suppose somehow we could store this internally as like, I don't know, a bunch of functions in a list or something, and then like apply them or add to them and then apply to them. I don't really know what the right way to do it is, but we could do that, or we could just have this map that takes care of our board state. Maybe we'll think about that later. Um, Another thing that's kind of interesting is, oh, I guess by default these are all empty, so um, that might be why this needs to return maybe result, because we're basically going to search for it in a map at some point. Not really sure. We'll see. This comes from, okay. Save this, F, package. We need containers. Restart this. Does it see it now? Data, map. I think normally we do the following. Import data, qualified data map as app or something. So you want the type constructor to be global, and then all the functions inside to be qualified. That's typically how we've been doing things. Whoa, what's up, 9 viewers? How is everyone today? Chat is basically dead, so feel free to say hi. Ask me anything. Also, check out this sweet shirt. I got my Hacktoberfest shirt. Did anybody else get one? They were free. Well, sort of. That was all contributions to Exorcism, actually, which was kind of cool. Well, not all, but some of them were. Okay, so now we're gonna write a wild instance, and by we're gonna write it, I mean it's been written for us, but m look up the position in the current state of the current board. That's what this get is, I think. I'll need to think about it. L. What's L? We'll see what L is here in a second. Oh, this is a position, so oh, but it doesn't even matter what these are. Why does it matter what this is? Oh, I see. So me is the player. So yeah, so I think I was right before. This get is from board, or I'm sorry, from the state T. Player. I think we're going to initialize this with a player. I need to look at these types again. Anyway, so we modify. I don't know what goes here yet. Okay. So these come from transformers, so we got to go get that. Package. And then we need import, control, monad, trans, reader, state. And then yeah, I'm trying to understand what's going on here. We need flexible instances, and then we'll see what we got here. So now that we're getting like actual errors, let's restart GHCI and then reload so that we get color. I don't know why it takes 2 to get color, but could it match type? Well, this is a board, right? So I think we need to return. Oh. So info takes a row and a column and makes a maybe player. So what's the type here? And this is like the same thing. So let's put a B here. Oh, this needs to be a result. So next turn. Turn pure next turn. Okay. So this lets us do some type checking because I'm a little confused at the types here. So this needs to be a reader T player, maybe player. So what we need is a maybe player, and then we'll return it. So that's where the lookup comes from. So we write a fmap get. We're supposed to be getting the state. So I think I need a lift. Is that what's going on here? Yes, it is. And then B should be a board. There we go. So now we should be able to do what we did before. M dot lookup to position row call fmap lift get. I think this is correct. Board position. Deriving eq board show. Board. Okay, so we just needed to lift the operation. Maybe they're gonna talk about this here in a second, but yeah, anyway. So ask is actually totally fine because ask is in the reader transformer. Jeez. Okay, so this one was modify. Well, we just need to stick a lift in front of it, basically. So, and this has to be m dot insert. Okay, so that's basically, I think, the answer. Now, one thing that's not happening here is we don't compute a win condition. So this is here a placeholder for the compiler. So that was sort of cool. I realized, you know, that the code was actually wrong and I need these lifts in here, which I didn't realize immediately. So that's kind of nice. Okay, so it says if we have a function like the following, Since reader t player state t board IO implements the tic-tac-toe and monad classes, we can just use logic as a value of this type. That means we can execute the game by then running each of the transformer layers. So you could do something like the following: run tic-tac-toe IO result board. Interesting. So really like, so this ends up being a little awkward, I guess, because to get an actual empty board, you need to write like which is sort of strange. Hmm. Interesting. Because that's the state. That's the initial state. That's different than this. So actually, we don't really care about this. This is just kind of an idea. So this is our initial player and um, our initial state. And sort of the interesting thing again is um, reader T over here is on the outside, but notice it's on the inside. So when you unpeel layers, you know, they kind of become inside out. That's one of the things that I think playing with these a lot is the only way you're going to get familiar with them. It's just about 9:30, so I think I'm going to take a little break to grab some more water. This is implement an algebra in final style for the custom monad you devised in the previous section. Well, we didn't do that. I really don't like these partial, like, show me the whole thing. Like, what is logic supposed to be? Wouldn't this only do one state? What I don't understand is how do we get to the end? Like, we need to continue to do this until we get to the end, and how does that happen? What's logic supposed to be? Like on the page where this is, this component, this piece right here is just a dot dot dot. This is kind of annoying. So, oh, I see. I think I see, but I don't see how the game will ever end. Okay, so here is the game logic. Why would this be here? Why would we want to modify the state? I don't think this needs to be, I don't think I want this here. So, or is this supposed to be, so this is coming from take. So it's like, I want to take row and column. All right. And then essentially so you need to like determine winner. Let's see here. So if winner, then pure winner me. No, pure what's the stupid thing called? Game ended. Game ended. Else do this stuff. I think, yeah, I think this is basically what would happen is you're gonna say like, if you just won, then return that the game is ended. Else do this. But there's definitely something missing here. Like there's a lot of stuff missing here because there's no checks for like if the game is ended, or am I supposed to check the game is ended in the logic? I'm not even sure. Or does the logic determine whether the game has ended? I don't know. I'm not entirely sure. Because we certainly don't want it to say your next move if the game's over. I don't know. I'm confused. I didn't want to do that, but oh well. Let's move this to tick, tack, toe, touch. Yeah, I know you're broken. Hang on. Alright, let's come back in here and continue working. I'm a little confused by that example. I don't like these partial examples. They really bother me. Like, please just show me the whole thing. Or provide me with a link so I can see the whole thing. Like one or the other. I would be fine with either. I don't like partial. I suppose I could probably just Google it, but anyway. Okay. So, we're gonna talk about another custom monad called FS. I'm gonna make it FS, sure. So write file, file path, string, either error, unit. Guessing it's either something like, okay. So is FS error a thing? No. So it did say back here what FS error stood for, so FS error is just an IO error. So let's just use IO error. So file path is just a string, I'm pretty sure. It depends what module you're in, but I think that generally speaking that this is just a string. Can I like even find out? Yep. So there you go. So this is one of those issues in Vim where these things get broken, and or it's in the terminal or Vim, I'm not even sure, but if they're too long, they don't quite work right. So you need to view these with a like an appropriate tool to find to deal with those links. Okay, so we now try to ascribe an FS type to a computation that also does random number generation. We are stopped by the compiler. In the following definition of F, we require the computation to work with any interpretation that understands FS syntax, whereas the use of random RIO would force the entire computation to work in IO. Okay. We want to write, I guess, something like this. Yeah, so we want to hide prelude. So import prelude hiding write file, read file. Okay, and then this comes from there. We probably need Nope. And restart that. It should be good now. What's it complaining about now? Oh, right. It's, yeah, this isn't gonna work. Why can't we just wrap this with a right or something? Why can't I just do... What does this complain about? I don't know. The error is weird, but okay, there's an error. I don't... Confused. Will this just magically compile? Is that the point? If I finish this? Very confused today. Maybe I just copied it wrong. Oh, I didn't copy it wrong. So that like specializes it. So what's IO error? IO exception. What is this complaining about? Okay, let's get rid of this. Although I guess that's kind of the whole point, but how do I deal with this if this is supposed to be unit? Oh, I get it. I actually need these. This is actually supposed to say prelude right file, I think. No. Oh. They really don't understand why these examples don't compile. Lord. Oh wait, no, this is what's supposed to happen. Oh my goodness. Sorry, I'm getting tired apparently. This is what's supposed to happen. So you cannot mix FS and IO actions freely. Okay. Can I just do this? We can probably do that. Now, what's unnecessary here? That's fine. All right, so if we do this, we would have to specialize F, I guess, to the IO monad and then it would work. I'm not really sure. So is this supposed to be like FS? Is this something you can write? Uh, why would this have this problem? Oh, right, I don't need these. So does that fix that problem? Lift F? Doesn't even do anything. What if we just delete it and then look at the type? Just file path to IO. Okay. You don't need those constraints, which I suppose is not that weird. Let's do the following. So cannot mix IO actions freely. Need to specialize get rid of this. Okay. Sorry, this is a little mind bending for me right now. Mainly because I'm expecting something to work, but not working. So it's a little annoying. Alright, so we're gonna need data map qualified data map as m. Wonder, let's make this map. Nope, wrong thing. Wrong thing again. Just wanted to format them, just being special. Okay, so we have now a mock file system. So we're gonna emulate a file system and probably write our instances modeled as a state, basically. So that reminds me, we're gonna need to import control monad trans state. So what we want is basically an instance fs state mock file system where. So write file is a path, which is just a string, and contents. So file system get, that's the current state, and then we want to put, what's the opposite of get? I think it's just put, but let's go look. State t. That's not what I wanted to do, but that's fine. State. Put. Yeah, we're gonna put the new state. We don't want to. Do we want to just modify the state? Because if we just modify, we don't even need do, I don't think. So we could say modify. So given the state or the map, basically, we want to do m.insert data map. Fine. Insert. This one. Thank you. So key A. So m insert. So it's just going to be partially applied. So super easy. We just write path contents, and I think that should compile. Oh, except it's map. Yeah, and this is literally just this. And we can remove these. Neat. I hope that's neat anyway. So that's like the wonders of Haskell. We don't need to do much. We just need to modify the state with basically just updating the state. Okay, so read file. Read file is a little more complicated. So we're going to, this time we do need to get the state. Maybe we don't. We might need to. I'm not even sure. We'll write this and go from there. So first we get the state, which is basically our map. So just call this M. for a lack of a better term. Or we could call it MFS for mock file system. And we'll put an A here just to get the compiler happy. What's this complaining about? So, oh, okay, now this is actually complaining. So, we need to add some stuff up here. And then we need to figure out what's wrong with this. Oh, the problem with modify is that, excuse me, modify, what's the prime form? Oh, strict to the new state. The problem with the modify function is that I'm returning the wrong kind of state. So I actually need to, I can modify and then get, or, well, put does the same thing. So the only way to, yeah, so I think I need to do modify and then get. So unfortunately that means we have to get rid of what we had before. Contents, do. So we're just gonna modify the state by inserting the path in the contents. And then we're gonna get the state. Huh? Do I need lift? I'm not even sure. What's this error? Okay. Expected type. State T. It seems to be having problem with type inference here. Oh, this is partially applied. I'm such an idiot. So we need to first get the mock file system. And then we need to modify it. Wait, but this takes the state. So that's our mock file system. All right. Sometimes the type semantics don't make any sense to me. So like, we can just do this. Right, and then that way I can just get right? Then I can easily just go back and forth. Right, so now this should be it's still a mock file system, but to modify it, I would need to get from it. So this time we're gonna say, well, let's leave the A there. We're gonna say, we wanna modify. Well, we can do the same thing. So it's gonna be m.insert path contents dot get mock file system. And then what we want to do is stick the return map into a mock file system. Map. Right? So I don't know what I was missing before, but like by making it a new type and then unwrapping and then wrapping, you basically are just ensuring that like you get what you want, which is, this is basically what I needed. So then I think I can literally just put a get here. No, because that gets the state. I just want an SMA. That returns unit. Okay, so let's see here. So the idea here is that we need to return actually the A type. And let me explain. The A type in this case is this. So we're not going to have any IO errors here, I don't think. We will have an IO error in the read case in case it doesn't exist. But in the write file case, we are just going to overwrite by default. So I don't really care about that. So I think that this is right. So this returns unit. So we should be able to like just write. I don't think we even need to fmap. I think that we can just write pure.write $, and be done with it. Oh, right. It's actually, you are right. It is an fmap. I think it's this. Yeah. Sorry. So that way we don't even need to do, because we're just going to get unit out of that. Well, we're going to get, this complicated FS state, blah, blah, blah. And we'll just map our write onto it. Okay, I sort of get this. So in the read file case, it's a little more complicated, only because like we want to look up the function, and if the function doesn't exist, we want to return a left. And if it does, we just want to return pure. So we'll do essentially the same thing here. Get, remember, is going to return our state, so we could just fmap onto that. our get mock file system, like so. And then this thing will be our map file string. So then that way we can just kind of use it. Although we might want to just keep it the way it was. I'm not sure. Because we're basically going to get a maybe back. Can we here. So we want to like do lookup, I think is what it is. So this is going to get us a maybe. Yeah, so this is fine. So we can do let result equals map dot lookup path MFS. And then down here, we just need to basically deal with it. So case result of, and again, this is like, we don't need to have this extra thing here. We don't need a result or anything. So it's like, instead of let, maybe, but I do have to deal with the result. Unless I'm misunderstanding what you mean. Like, I suppose we could do like we could do a lambda case or something, and then just fmap that. If we wanted to. I think. We'll see. So what are we getting back out of this? We're getting the contents. So then we just pure write contents. This needs to be an IO exception, right? So an IO exception or an IO error. How do we? Can I just call an IO error? IO error. I don't know. It might be. It might just get a little long because we're basically gonna have like. I guess we're gonna have like a lambda case here, and then fmap get mock file system. So it's gonna be like a long call, and it might look a little funny. I don't know how to raise an IO error, but that's what needs to go here. So I just need to figure that out. Uh-oh. Uh-oh. Oh no. Oh no. Google, no. Google. No. Haskell status. Status.haskell.org. Oh, this is different. Oh, I thought it was here. Google, come back. Okay. Google's broke. Although I think that if I was smart, I installed the tool here. And I'm not. So we're gonna just have to use regular old Google. So how to return IO error from function Haskell? Okay, there's no IO error in this at all. No. Search instead for this. Hackage. Okay, hackage is okay. Here we go. So we want a user error, right? String to IO error. So we'll say, we'll get this. And we'll say pure dot left dot user error I don't know, something like this. So I think, yeah, I mean, it compiles, right? So the types are at least right. It might not behave correctly, but the types are right. So I think what we could have done, which I think would be a little weird, is something along these lines. And I think it's just, so this is kind of what Lumi and I were talking about. If you're, whoops, if you're not unsure of what we were talking about, I'll show you. So we could have used the lambda case here and fmap to do like some sort of voodoo magic, I suppose. Really not that bad. So you can basically just copy these. Oh wait, no, because I need path. Oh, I have path. Yeah, so this would work. And then if we like I think this would compile. Really? Is this one of the ones that it can't figure out? Fine. Oh, okay. I can't do this. Right, because these pures, they're not quite right. The returns don't work if we're not in the do block. So actually, I don't think we can do this conveniently. We would have to like place this or replace this with the much longer constructors, which we're not going to do. But you know, you could do it. I guess it's ugly, and I would not do it. This is much more readable. We don't need this anymore. The other thing we can do is do pure and remove these. We don't need both of them. You got to be careful. Well, not really be careful, but that's basically, this is basically the same thing. What else can we do? Yeah, no worries, Oren. We're almost done anyway. I'm probably gonna actually I might just stop here, so yeah, I think I'm gonna stop here because the next section is called initial style. So we talked about final style. Um, so final style is sort of the system that we did here, where you have this M as a return type, and then you, I guess, what's the right term? You specialize via instances, and then you can use those instances. So like this is an example where you wouldn't be able to write this function unless you could specialize M to IO in this case. Although I guess you would just write file path IO. So I'm not sure why this was the example chosen. But anyway. Okay. So yeah, that's it for the day. Just as a reminder for everyone. So this book that we're doing is available on Amazon. You can just get it at that link there. I'll bring it up real quick. I haven't brought it up in a while, so I think it makes sense. Oh, also, did you know about smile.amazon.com? You can actually support Haskell by just going to smile.amazon.com. You saw that little pop up there. So I try to buy all my stuff on smile.amazon.com. Maybe I should put that there just as a reminder that it exists. Or make it a command or something. So anyway, you can get this book. It's about $50. The typesetting's really pretty. There are a few sort of differences between versions of GC. By the way, our Nobiz, thank you for the follow. I just noticed. Apologies for not announcing that sooner. I really appreciate that. I think you're 162 followers. I should probably do something cool for 200, but I don't know what. So if you have any ideas for what I should do at 200 followers, let me know. Also, feel free to tell me what you're into, Haskell, programming, whatever. I like hearing what my viewers are doing these days. So anyway, you can get the book there. You can also look at the code that I've written here. So this is all the code, and I try to keep it as up to date as possible. It's not in the most beautiful state ever, but it exists, so you can go look at it. And the other thing is that on my YouTube channel, you can actually watch every past one of these. So I have a playlist here for Book of Monads, and oh, why are these here? Why are these on my whatever? You can just play all of them. So if you wanted to do that, there's currently, oh, I don't know, it doesn't actually say here, but there's, let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18. About 22 hours of material here, so watch it at an increased speed. But anyway, yeah, it's all there.